Good morning, dear students. My name is Ferhan Mazher, and today is 25th of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve alternative to practical ATP. We call it paper 4, and we have selected October November 2016 4 2 paper. This ATP paper belongs from the zone 2, and the time allowed to complete this paper is 1 hour. So let's start this paper. So the October November 2016 4-2 paper 4, alternative to practical. 1 hour is allowed. So let's start this paper. Okay. A student is to determine the density of a liquid. She pours the liquid into a measuring cylinder as shown in the figure 1.1. State the volume V of the liquid in the measuring cylinder. So if I increase the size of this, so you can see it more clearly. You'll see here. So the 60, 62, 64, 66, 68, and 70. So the reading is 64 centimeter cube. So the reading is 64 centimeter cube. Let me show you. So the reading is the 64 centimeter cube. He says her friend also measures the same volume of liquid in the measuring cylinder, and she records a larger volume than the correct value in the A first part. Suggest how she makes the error. I think that she has made a parallax error, and she has positioned her eye not in the correct position, and she has not positioned her eye perpendicular to the scale from where she is taking the reading. So if her eye has been perpendicular to the scale from where she was checking the meniscus, and then there will be no parallax error. But if she positioned her eye below that level or above that level, then she will have parallax error. So we think that this happened due to the wrong positioning of her eye with the scale, and that created a parallax error. She made parallax error. Her eye is not positioned correctly to the scale. So that's my answer. So let's move to the next part. He says, state another piece of apparatus that the student needs in order to determine the density of the liquid. To find out the density of the liquid, you should know the volume and the mass of the liquid. To measure the mass of the liquid, I should use balance, electronic balance, you can say. So let's check the answer. It says, to measure mass, balance is needed. Then their question is, explain in detail how she uses her apparatus to determine the density. You see, the procedure is very simple. What she will do, she will take an empty cylinder, put it on the balance, and she will measure what is the mass of the empty cylinder. And she will call it M1, and then she will pour liquid into the measuring cylinder, and she will note down what is the mass now, and she will call it the M2. Then M1 will be subtracted from the M2, and that will be the mass of the liquid. She will note down what is the volume of the liquid from the measuring cylinder, and then she will divide the mass with the volume, and that will give her the density of the liquid. So my answer is, place empty measuring cylinder on balance and note mass M1. Pour water into measuring cylinder and note mass M2. Mass of liquid will be M2 minus M1. Note volume of the liquid V from the measuring cylinder. Divide the mass of the liquid by the volume of the liquid to calculate density. So that is our answer. So that was the question number B. Second part, he says, her friend also determines the density using her incorrect value for the volume. State how her density value compares to that of the student, because her Her friend has noted larger volume. So, the density is mass divided by volume. So, if the mass is still the same and the volume is larger, then the density value calculated by that incorrect volume, due to that incorrect volume, will be less than the correct value. So, let me show you my written answer. And here we go. So, her density will be less as compared to the correct value of the density. So, let's have a look at the marking scheme. So, my dear students, the marking scheme of the question number 1 is showing up on your screen. I have already checked my answers with the marking scheme, and you can also pause the video and you can take your time and you can check the marking scheme. It is always a good habit to check your answers, your teacher's answers, compare them with the marking scheme. It's a very, very important habit. Okay, so we are done with the question number 2. So we are going to the question number, next question number 2. The inner core of a pencil is known as the pencil lead. It is made of carbon, a conductor of electricity. A student measures the resistance of a 12 centimeter length of the lead as shown in the figure 2.1. So just how the connecting wires can be connected to the pencil lead at A and B, you can use the crocodile clips. And the crocodile clips can be connected with the wires, and those wires, crocodile clips, can hold from point A and point B. So this is use crocodile clips. Let me show you my answer. Okay, so my answer is use crocodile clips. Then the next question is, a micrometer is used to determine the average diameter of the pencil lead. Explain how it is used. You see, in the micrometer, you take the lead and you place it between the spindle and the stud of the micrometer, and then you rotate that thimble, and at the end, when the spindle and the stud has gripped the lead, then use ratchet to and rotate the ratchet until the ratchet's wheel starts slipping. Then it means that the spindle and the stud has tightly gripped the has tight grip around the lead. Then take the reading from the micrometer, that will be the diameter. Then what you can do, you can take the diameter reading from different positions, different locations on that lead pencil, and then take the average of the diameter. So let me show you, let me read the written answer. Place pencil lead between the spindle and the stud of the micrometer. Use ratchet to make firm grip around the lead until wheel slips. The wheel of the ratchet starts slipping. Note the reading, measure diameter from different positions, and take average. So this is my answer of how you use a micrometer to find out the reading. Okay, so we are done with this. This is our 2-mark question. Then he says the measured resistance X is 341 ohm. The diameter D of the pencil lead is 0.050 centimeter. The length S of the pencil lead between point A and B is 12 centimeter. A constant P for the material of the pencil lead is given by the relationship P is equals to X pi D square divided by 4S. Calculate the P in the ohm centimeter. Give your answer to two significant figures. Okay, so your answer should be in two significant figures. You just have to put the values here. The X value is 341 multiply pi multiply 0.050 square divided by 4 divided by 12. So you will get the answer. So let me show you how this is done. Okay, so you can see that I have substituted the values there, and 341 multiply pi multiply 0.050 square divided 4 divided 12 equals to, and it will give you 0.0558, and when you round it off to the two significant figures, it will be 0.056 ohm centimeter. Hope you understand. So let's have a look at the marking scheme first, because crocodile clips, closed jaws, and the final answer will be 0.056. So our answers are right. Question number 2A part is done. Okay, then he says Question number 2 and its B part. The student uses the same pencil lead to draw a thick black line 0.20 centimeter wide on a sheet of paper. He measures the resistance R between 2 points that are 20 centimeter apart as shown in the figure 2.2. He repeats the measurement of resistance for different lengths L of the black line. The student's results are shown in the figure 2.3. So here for the length 820, the resistance is 1865 kilo ohm, and for 16 centimeter length, the resistance is 1470 kilo ohm. So 12 centimeter, it is 1052 kilo ohm. For 8, it is 8 centimeter, the resistance is 781 kilo ohm, and for 4 centimeter, it is 330 kilo ohm, and for 0, it's 0. Okay, on the figure opposite, plot the graph R on the kilo ohms on the y-axis against the L in centimeters on the x-axis. Start your graph from the origin. Draw the straight line of the best fit. It's a 4-mark question, and this is that graph paper which is given to us, to figure 2.4. Let me show this empty thing. Let me reduce the size so you can see the whole thing. So this is that graph paper which is given to us. So let me show you. I have done this. Okay. So here we go. So this is the graph paper, and I will label it. And here I have written the length in the centimeter. Here I will have the resistance in kilo ohm. I forgot to write that, but you are supposed to write it here. Here you see I have labeled 5, 10, 15, 20, 25, 30 centimeter. Here it is 200, 400, 600, 800, 1000, 1200, 1400, 1600, 1800, 2000 kilo ohm. So this is labeling, very important. Then I plotted the graph. I plotted the points. The points were, I know those points. Let me read. At 0 you will have 0. At 4 you will have 330. At 8 you have 781, so approximately 780. At 12 you have 1052, so 1050. And at 16 you will have 1470, and at 20 1865. So I have plotted these points. You can see these points, I have plotted them according to that table 2.3, the figure 2.3. And then I have joined them with the line of the best fit. The line of the best fit is a line which passes in that pattern through those points, and we try to make sure that the points which are left on one side of the point, the same number of points are left on the below the line. So this is the line of best fit I have drawn. And now so that is the so that was the question number 2B, first part. It was a 4-mark question. In the next question, he says, determine. Let me show you. Let me show you the next part. The next part is determine the gradient G of the line. Show clearly on the graph how you determine the G. Okay. So that's the question number 2B, second part. And here you can see I have made a triangle here. This is my run. This is my rise. I will divide this rise with this run, and that will give me the gradient. So 1370 divided by 15, and that will be 91.3. So approximately 91. So the gradient is 91. Then their question is, use your value of the P from the A third part and the G from the B second part to obtain a value for the depth D of the carbon layer in the pencil line using the relationship. So D is equals to P divided by 200 G. So just put the values here. The P value is 0.056, and the 200 and the G value is 91. So when you do this calculation, the answer is 3.08 expo minus 6 centimeter. So hopefully you understand. So let's have a look at the marking scheme. It says, so we have labeled the quantities. That was a 4-mark question. Then you have 93 plus minus 2. Our answer is right, the gradient. And then this is the third part. So we are done with the question number 2. Okay, so the question number 3 is showing up on your screen. He says a student investigates current in a diode. So that is the graph of the current in the diode. And he says the shape of the student's graph is shown in the figure 3.1. The student has a resistor of the resistance 330 ohm. The resistors has 3 colored bands to indicate the value of its resistance as shown in the figure. So black means 0, brown means 1, red means 2, orange means 3, yellow means 4. So the resistance is how much? 330. So it means 33 multiplied 10 raised to power 1. So the first color represents the digit, the second color also represents the digit, and the third color represents the multiplier. So let me show you how, what do I mean. Means 33 multiplied 10 raised to power 1. So first these two numbers, they are digit, and this represents the multiplier. Multiplier means 10 raised to power 1. Okay, so 330 is basically 33 multiplied 10 raised to power 1. So the first band will represent this, and the 3 means orange. So first band will be orange. This is the second digit, that is 3 again, and so it will be orange. The second band will be orange, and the third represents the multiplier. Multiplier means 10 raised to power 1. So it's 10 to power 1. So for 1 it should be brown. So the colors, first color will be orange, second color will be orange, and the third color will be brown. So it's orange, orange, and brown. Let me check. Orange, orange, brown is the answer, sir. Okay. We are done with the A part. Now we are going to the B part. The student uses the resistors in series with the diode to protect the diode. He sets up a circuit to measure different values of the current in the diode and the voltage across the diode. In the space below, draw the circuit diagram the student can use. It's a 3-mark question. So let me show you. So here you can see I've drawn that diagram. Here I have shown a battery, and then I put an arrow here. It means this power supply is a variable power supply. You can change its EMF. Here is the switch. Here we have a resistor. I have only connected here one resistor. You can connect here 2 resistors also. Here is the diode. I've connected an ammeter which will read how much current is flowing through the diode. And then parallel to the diode, we have put the voltmeter that will tell you how much is the voltage being used by this diode. They say B part, power supply, fixed resistor, and diode, any orientation in series, ammeter in series with diode and resistor, voltmeter across the diode. So our answer is right. Okay, that was a 3-mark question. The C part is, he says, explain how the student can take readings for different values of the V. So what they will do, they will close the switch, and they will note down what is the reading on the voltmeter and what is the reading on the ammeter. Then they will open the switch, and then they will change the EMF of the power supply. And then again, they will close the switch and note down what is the reading of the voltmeter and the ammeter. So this is how I think. Okay, close the switch, note reading on the ammeter and the voltmeter, change EMF of the power supply, and again note. I have written here not. This word is note. Basically, this word is note. Here is an E. Change. It's taking time. Okay, so it's changed. So I am looking for. So here this word is note. Okay. Okay. Then he says the diode conduct current in one direction and does not conduct in other direction. State how the circuit can be changed to show this. You can reverse the battery, and when you will reverse the battery, you will see that the ammeter will show that there is no current flowing. That shows that the diode let the current flow in one direction, and in the other direction, reverse direction, it will not let the current flow. So reverse the power supply, reverse the power supply, and that will not let the current flow. So reverse the, so let me see. So reverse the power supply, reverse the diode. Yes, you can also reverse the diode, and the current will become zero. A student is given a lump of blue tack which he molds into a cube. The blue tack is like Play-Doh. The front face of the cube is shown full size in the figure 4.1. By taking measurements from the front face of the cube in the figure 4.1, determine the volume in centimeter cube of the blue tack. So I will place a scale along this side. I will measure how much is the length and how much is the width, because it's a cube. Length, width, and height, they all are equal. I have measured it, and that length is 3 centimeter. So the length is 3, width is 3, height is 3. So the volume will be 3 multiply 3 multiply 3, and that will be 27 centimeter cube. So 27 centimeter cube. And the answer is 27. Yes, sir. Our answer is right. Then he says the student rolls the blue tack into a cylinder as shown in the figure 4.2, cylinder of the blue tack. He places one of the ends of the cylinder on a piece of 2 millimeter graph paper and draw around it as shown. So what we will do basically, so unfortunately there was something happened with the internet, so the things stopped. So it's back. Okay, so I'm really sorry, something happened with the internet. And so I was on the question number 4. So the volume of that thing was length into width into height, and that was 3 into 3 into 3, and that was 27 centimeter cube. Then okay, so we were supposed to count the squares who were inside this figure. So I have counted them. They are 123 squares. 123 squares. And then the last part, using your answer in the B first, estimate the area. So we have estimated that there are 123 squares. So each square is 4 millimeters square. So it will be 492. So it's approximately 492 millimeter square. So I have rounded it off to 500 millimeter square. So I think that is 500 millimeter square. So let's check. So whatever is the number of squares, you just multiply. So my dear students, today we have done October, November 2016 Physics 5054 4-2 paper. And today we have completed its all questions in this video. During this video, due to something happened with the internet, there was some problems. So there will be 5 or 6 10 seconds delay in the video. So I am sorry for that. That happens. We are in Pakistan. And if you think that this video is interesting and has helped you to learn something about the ATP paper, it has helped you to do the ATP paper by sitting at your home. So do like this video and share the link of this video onto your Facebook account, onto your Instagram account, into your WhatsApp groups. Share the link with your class fellows, because that will help me to promote this channel and this video. Also subscribe my channel. So thank you very much. It's a great blessing for me to teach you all online. Thank you very much. Have a good day and God bless you all.